Welcome back. This is the final lecture for week 3. In this lecture, we're going to be talking about the purchase of utilities, or comparison between two utility rates. A frequently asked question, especially of energy auditors, is a building owner is going to have a number of choices available to do the same end process. So they're going to have a number of utility choices. They can run a particular process with electricity, they can run it by propane, they can run it by natural gas, they can run it by fuel oil if they need to. The important part to the customer is they want to use the least expensive utility to get the same end result. So the question becomes, how do I compare two utility costs? So here's an example comparison. Customer has a choice between electrical or natural gas for a heating application. So the information that we're given is currently electricity cost about 3.77 cents per kWh. The system efficiency overall for this process that's using the electricity is about 90%. The other way the customer can go is they could use natural gas with a system efficiency of 80%. What we want to find out is what would the cost of natural gas be to actually equal what the electrical cost is. So where's that break-even point? So doing this comparison, first we want to write down the facts that we know. So we know all the information on the electrical side. We know the cost, we know the BTU content for electricity, and we know the efficiency of the process, the overall process. Natural gas is what we're contemplating. We want to know where these two equal each other. In other words, what would the natural gas cost have to be to equal the electrical if I'm getting 100,000 BTUs per therm and an efficiency of 80%. What you see here is the equation to set up to get an equivalency. In other words, comparing one fuel against another. Where do they actually equal each other? If I take that equation at the top, which is basically fuel 1 cost, divided by the efficiency of that process, times or divided the overall by the fuel energy content, will equal the same type of calculation against fuel 2. Now, rearranging the equation, I'm going to solve for the cost of fuel 2. In other words, I'm trying to find out where the cost of fuel 2 actually equals the fuel cost 1, or where does the process equate with each other. If I plug in the value from the example from the previous slide, it turns out that natural gas would equal the electrical process if gas cost 88 cents per therm. So I can take an actual look at what's going on with the situation. And if I can go out on the market and currently buy natural gas at 49 cents per therm, then that's actually less expensive overall, considering the efficiencies of the process, than the process being run by electrical. Now, it's important to note, and I'll probably mention this a few times, this is simply looking at the utility cost. This is not calculating the cost of purchasing new equipment, retrofitting the equipment to switch over between the fuels. This is simply which is costing me more from a fuel standpoint. We have another example, example 2. In this case, a customer is using a propane furnace for heating at a cost of $2.10 per gallon of propane. The efficiency of the current system is 0.89, and this particular customer is considering going to a ground source heat pump. Now, currently the electrical costs are 11 cents per kWh, and we have a COP of this ground source heat pump of 4.2. Is switching to the heat pump a good idea? So that's the second form of the question we have. So again, state the facts. In this case, we know the customer's already using a propane furnace. They're paying $2.10 a gallon for the propane. The BTU content is 95,000 BTUs per gallon, and the overall system efficiency is 89%. What we need to know is find out what the electrical cost has to be where it actually is equivalent to the propane. So I'm trying to calculate the electrical cost. Now I know I can purchase electricity at 11 cents per kWh, but is that where it breaks even? Is that less? Is it more? So where are these two things equal? So the BTU content for the electrical is 3,412 BTUs per kWh, and the efficiency at the 4.2 COP is actually 420%. If I run the calculation, put it in the formula that we had already, electricity to be equal with propane would have to be 36 cents per kWh. Now right now I can buy electricity for 11 cents per kWh. So electricity is currently 3.27 times less expensive to run the same operation. So depending on the cost of install, whether the customer is going to be happy with a ground source heat pump, whatever, looking at it from a purely utility standpoint, this is a no-brainer, going to the ground source heat pump. This ends the final lecture of week 3. When you're ready, you can proceed to the assessment for week 3, followed by week 3's lab lecture, and then week 3's lab. Thank you.